Clojure and MQTT, and a bit of Java. So I realized this morning when I was watching the first talk, Alexander, the first talk from Alexander, I'm actually going to have part 2 of that talk. And I wrote a bit of an MQTT broker with Java and Clojure. So MQTT very quickly is a publish-subscribe protocol. So you've got clients connecting to a broker. A client can publish a message on a topic, and clients can subscribe to a topic, and they get then all the messages which are published on that particular topic. And that can be like any kind of topic and any kind of data. It's just a bunch of bytes, basically. Designed to be low bandwidth and energy efficient, so mobile applications, IoT, Raspberry Pis and stuff like that. Supports 3 qualities of services, fire and forget, at least once and exactly once. My implementation of the broker only does 0. It doesn't do the other one yet. It's an Oasis ISO standard and free to implement for everyone. There's libraries out there for Clojure, you name it, Rust, C, C++, Java, JavaScript, and it's freely available. And that's all I'm going to tell you about MQTT, basically. HTTP kit. Who has heard of HTTP kit? Excellent. So HTTP kit, you wonder, where does this come into the picture? But let me tell you something quickly about it. So it's a Java Clojure web server written by a guy called Feng Cheng in 2012. And when it first came out, he announced and said, look, I've got a web server which supports 600,000 current connections. And everyone like, oh yeah, that's cool. And his web server is completely asynchronous. It's ring compliant, which means you get a map as a request and you return a map as a response, just like in Ring does, so you could port any Ring application relatively easily to it, and it's really, really small. It's actually 3,800 lines of Java in there and 450 lines of Clojure code. You know, it's actually more Java than Clojure, yet it's a Clojure web server. When I read about it, I thought that's pretty cool. And as you guys said, you heard about it, so you might think that's cool as well. And that got me thinking, how can I combine that with MQTT? So HTTP as a protocol is very simple in respect there's a request coming in, and there's always a response coming back. Now, a response could be as simple as a 200, okay. Yeah? It's just a bit of data going back. There could be a body or not. There could be a failure, a 404, a 403, but it's very much a one-to-one relationship. MQTT, very different. It could be an incoming message and a response message to that. So, for instance, a client could send a connect message to a broker, and then there's a connection acknowledgement, going back. There could be a message just coming in and no messages going out. Or worst case, there could be one inbound publish, and there could be hundreds or thousands or tens of thousands clients subscribed to that particular topic. So one incoming message could result in thousands of messages going out. So that makes MQTT a very different protocol from HTTP. And I was wondering if I could use still the ideas behind HTTP kit and its asynchronousness and translate those to MQTT. So and that comes, and well, sorry. This is a quick example of an MQTT packet. So there's a control header, starts with 1 byte, then there's 1 to 4 bytes, which is encode the packet length, then there is 0 to y bytes, the variable length header, and there's the payload. And as you see, these are all variable. You have to read the packet bit by bit, basically, and byte by byte, and figure out what's coming next, which is not particularly nice. Here's, for instance, an example of a connect packet. The first byte on there is the connect packet. There's one single byte in there that says this is a connect packet. There's the length. There's the protocol name, which is a string. So it's 2 bytes for the length of the string, and then the rest of it. What's next is the protocol level, for instance, that says which level of the protocol you're on. Connect flags, here's some examples of the connect flag. So username flag, bit 7 is turned on. Some various other things, password flag. And all these things are very, as I said, they're down at the bit level. And that brings me to MQTT cat. No, HTTP kit, MQTT cat, yeah, very clever. Took me a long time to come up with that one. It's probably the best bit about the whole thing, actually. Just the name. And I was thinking, yeah, I could do all that in Clojure, but you can do in Clojure. There is actually in the core library, there's all these functions available to do bit manipulation and stuff like that, but actually you don't. Why just not do it in Java, you know, because it's already there and it's all typed. And of course, you can't read this, of course, which is great. But I've got a bit of Java code here that does all that bit fiddling, you know, which bit is set on, turned on, you know. And as I said, why would you want to do that in Clojure? It's not, I don't think it has any advantage doing that in Clojure over doing that over doing it in Java. So I just did it in Java. But the nice thing is you can actually mix the two. And you can just about read this hopefully here. I'm making Clojure keywords here. You just, it's an import static Clojure lang keyword intern, and in there I call the intern function with a bit of string, and that actually becomes a Clojure keyword. Yeah? So from Java, you can go to Clojure. Yeah? And there's another bit of code here, which you probably can't read either, but I'll try and explain it. So we create a map, object, and it's a tree map, object, and we put in the map packet type, so that is one of those keywords we just created, and we give it actually another keyword, connect, because this is a connect packet. Yeah? Client key, it's a string we point out somewhere. So we get the flags, the protocol name, and then the username set, for instance. Yeah? We set the bit earlier on, whether the username is set or not. This is that particular thing. Yeah? We set whether the username is set, and that's that bit in there. And then you turn it into a persistent array map. I think that's what it says. And then, voila, you go to Clojure, and suddenly we have a map as we like it and as we love it. This is just data, and now we can operate on it. And so all the low-level bitness of the protocol is implemented in Java, you know, sending and receiving the bits. Everything that's higher level, as soon as we go off into a map, we decode all the, encode all the incoming messages into Java's Clojure maps, and then we go into Clojure land, and then we operate them, and then we implement the higher levels of the protocol, like logging in, stuff like that, in Clojure. And that's where the value of Clojure is, because that's where the more complicated stuff is happening. So things I've learned on this is that there's actually a line pom command which generates a pom file, and then you can import it in IntelliJ or Eclipse, for instance, and you get nice editors and with syntax highlighting, and it compiles things for you on the fly and tells you whether you've done things wrong. So that's really, really easy to use. And then, of course, Alexander told you about line Virgil already and showed it to you how it worked, which, of course, I can't do. And there's some links and sources. So my MQTT broker, I admit, it's incomplete. It will, for instance, always respond with a connect acknowledgement success, even if it's completely wrong. It fails half the time. It can send some messages, but I can subscribe to it. If you want to see it in action later on, come and see me. I can probably show you something. And there's some links on here, which you can't read as well either, of course. But they're on there. Thank you very much. Thank you.